Section 5, Day 2 is all about solving polynomial equations. So there are 4 words that we're going to use synonymously. They mean the same exact thing. They are solution, root, zero, or x-intercepts. All of those mean the place or places where your graph crosses or touches the x-axis. So because they are x-axis values, they are x equals, or written as ordered pairs, which we'll discuss a little later. In factored form, roots or solutions are super easy. For the first one, I'll show you why. Because if you look at the first one, you've got 2 things that are being multiplied by each other, and your end result, your product, is 0. So technically speaking, one or both of them should be 0. So that's what the root theorem says. You just take one of them at a time, set it equal to 0, and solve. If I add 9 to both sides, I get x equals positive 9. For the second one, I can do the same thing. Take that x plus 3, set it equal to 0, subtract 3 from both sides, I get negative 3. So technically speaking, you're taking every factor that you have, setting it equal to 0, and solving. If you take a look, though, there is a shortcut. Focus on the signs for a second. When the factor is x minus 9, your answer's positive 9. When the factor is x plus 3, your answer's negative 3. You'll notice that from factor to root, your answers are opposite signs. Now, that works out when the constant or the lead coefficient is 1. So if you take a look at both of those factors, it's a 1x minus 9 and a 1x plus 3. When there's a number in front of it, like that 2, if you take the factor and set it equal to 0, solve it. Adding 1 to both sides gives me 2x equals 1, and dividing by 2 gives me x equals 1/2. I always remember the shortcut on that one is the constant over the coefficients. Let me show you what I mean by that. Looking at that factor again, the constant is 1 and the coefficient is 2. The constant is 1, the coefficient is 2. So it's 1/2 positive because the opposite sign still takes effect. For the second factor there, this 4 minus x, if you take that, set it equal to 0 and solve, you subtract 4, you get negative x equals negative 4, and dividing by negative 1 gives me a positive 4. The whole opposite sign thing still takes effect. So use your shortcut for number 3. This x plus 4 gives me a root of negative 4. The minus 3 gives me a root of positive 3. And the 3x plus 5 gives me a root of negative 5/3. You'll notice in this one I listed them all with commas, no parentheses, because they're not an ordered pair or triple. You're more than welcome to do that, or you can list them out separately. It's up to you. Pause the video to do the U-trials. So here, they're just going to have them not in factored form. As long as you get your polynomial to be factored, you should be good to go. So I'm going to start by factoring this. 2 numbers that multiply to negative 6 and add to negative 1 would be minus 3 and positive 2. Once it's in factored form, your roots are opposite. So I get a positive 3 and a negative 2. Taking a look at number 2. 2 numbers that multiply to negative 10 and add to negative 3 are minus 5 and positive 2. Roots from those factors would be a positive 5 and a negative 2. So as long as you factor it first, you should be able to find the roots from there. Make sure you factor your polynomial completely before attempting to find an x, and that means always looking for a GCF first. Remember, when factoring, GCF is the first line of attack. So taking a look at number 3. GCF here is a 2x, and if I pull a 2x out, I'm left with an x minus 2. Every factor is going to give you a root. This first factor gives me an answer of 0. If the GCF out front has a letter, you get a root of 0. And I'm actually going to replace the word root and say 0. It's bizarre, but that 2x, that 0 is 0. The root is 0. The second one, x minus 2, this one here, gives me a positive 2. You'll notice that the number of roots you have when you're done, in this case 2, matches the highest exponent in the problem. They should match. If that highest number in the air is a 2, you better have 2 answers. Number 4. First thing I'm going to do is pull out the GCF of x. Leaves me with an x squared minus x minus 12. So I'll keep my x out front. Two numbers that multiply to negative 12 and add to negative 1 are a negative 4 and a positive 3. So my roots are 0 from that x out front, 4, negative 3. 3 roots matches the x cubed I started with. Number 5. Number 5 is a special factor. You'll notice it's the difference of two squares. It breaks up into an x plus 4, x minus 4. The first factor gives me a negative 4 as an answer, and the second one gives me a positive 4. I do want to write this a second way for you so you can see it. This is the same as plus or minus 4. You can write it either way, it doesn't matter. It's still both a positive 4 and a negative 4. Factor number 6, two numbers that multiply to 25 and add to negative 10 are negative 5 and negative 5. So my roots are 5 and 5. That's okay, it's something we'll learn about in a second. Those roots match, not a big deal. But they are both positive 5. That fact that they're both positive 5 is called a multiplicity. So if they say multiplicity, it just means how many times it occurs. So a multiplicity is how many times it occurs. The multiplicity of that x in number 6 is 2. So we would say x equals 5 with multiplicity of 2. It means it occurs twice, like twins. X equals 5 with a multiplicity of 2. All right, number 7, GCF this one first. I'm going to pull an x out. Leaves me with an x squared minus 4x plus 4. Two numbers that multiply to 4 and add to negative 4 are negative 2 and negative 2. So x minus 2, I'm going to write it like that with a little 2 in the air. Just means there are 2 copies of it. So this first factor of x in the front gives me a 0 of 0. And that negative 2, the x minus 2, gives me a positive 2 with a multiplicity of 2. I want to clarify. This 2 came from the fact that that factor is an x minus 2. And this 2 came from the little 2 in the air. Number 8, that x plus 3 cubed gives me a root of negative 3 because it's opposite inside. But that little 3 in the air tells me I have a multiplicity of 3. Pause the video to do the U-try. Make sure you set your equation equal to 0 before you solve. So if you take a look at number 1, that 63 needs to come over by subtracting. Gives me 3x squared minus 12x minus 63 equals 0. GCF it. The GCF here is a 3. Leaves me with x squared minus 4x minus 21. Two numbers that multiply to negative 21 and add to negative 4 are negative 7 and positive 3. That 3 out front does not give you a root. It doesn't have a variable with it. It's kind of garbage, to be honest with you, when it comes to the graph. It just stretches it. So my roots are positive 7, negative 3. Number 2, I'm going to start by adding the 6x squared. And when I do, I'm going to put it behind the 9x cubed so it's in order. What I really have is 9x cubed plus 6x squared minus 3x equals 0. The GCF here is a 3x, which leaves me with a 3x squared. So you're looking in this one with a guess and check. Good news is it's factors of 1, which makes it considerably easier. There's going to end up being a minus here and a plus here, which makes your 3 roots 0 because of the 3x in front, positive 1/3, and negative 1. Pause the video to complete the U-try.